In this lecture, we now want to talk about how you add and subtract rational expressions. So there's two types of problems I'm going to work with. The first one's going to be very easy. It's when they have the same denominator. Okay, so when fractions have the same denominator, so for example, if you have a over c plus b over c, if they have the same denominator here, the same bottom, you can just add the numerator. So you go a plus b over c. And it's the same with subtraction. If you have a over c minus b over c, this is just a minus b over c. Okay, so you need to have a common denominator to add or subtract fractions. So it's the same with rational expressions. So I just want to do one quick example of, here in this case, subtracting rational expressions with the same denominator. So I have x divided by x plus 1 minus 3x plus 2 over x plus 1. So they have the same denominator. So it's just super easy. You can just straight subtract. So you're just going to subtract the numerators. So this is going to be x minus. So now here's the important thing, and a lot of people can make mistakes like this. You're subtracting away this entire quantity. So it's x minus, in parentheses, 3x plus 2, all over the common denominator here, which is x plus 1. All right, so now all you have to do after this is just clean it up. Okay, so let's distribute the negatives. So you get x minus 3x minus, so minus plus becomes minus 2, all over x plus 1. So x minus 3x, you can combine the like terms here. This is minus 2x minus 2 over x plus 1. Okay, so you have to keep simplifying if you can. Keep simplifying if you can. So notice how each of these in the numerators has a negative 2 in it. So let me factor out the negative 2. So when I do that, I'm left with, when I factor out the negative 2, x plus 1 all over x plus 1. So do you see why you need to, after you perform the operation of addition or subtraction in this case, you have to simplify. Because the reason what you see here is they both have the numerator and denominator have a common factor. And this just simplifies to negative 2, which is great. Okay, so perform the operation, then simplify. Always, always, always. All right, so there's not much more to do with rational expressions that have the same denominator here when you add or subtract them. It's really, really straightforward. What I want to spend our time on is adding and subtracting rational expressions that have different denominators. All right, so what you're going to have to do here, it's a little bit of a process, and I'm going to have 3 examples for us. The first thing you're going to have to do is you're going to have to find the LCD of the rational expression. So this can be tricky. All right. All right, but I'm going to show you, in 3 examples how to do this. I'll start with some easy ones, and then I'll work to some harder ones. Then you're going to rewrite each rational expression as the equivalent expression whose denominator is the LCD. So all the expressions, right, you're going to have to write over the LCD. So to do so, you multiply the numerator and denominator of each rational expressions by the factor or factors needed to convert the denominator to the LCD. All right, this process will be after you see me do an example or two, I promise it will be kind of straightforward, or it'll seem a little bit easier. Then all you're going to do is, once it's over the LCD, you're going to add or subtract the numerators, all right, and you're going to place the result over the LCD. And then if possible, always check to see if you can simplify. Okay. So the hard part, all right, the hard part is finding the LCD. And let me just show you just like a simple problem, just with normal fractions. Like if you wanted to add 3/4 plus 1/6, right? What you would do is you would say, okay, what's the LCD of 4 and 6 here? It's 12, right? So what you would do is you'd multiply this by 3, this by 2, and then whatever you multiply in the denominator, you have to multiply in the numerator. And then over the LCD, you just add. So it's kind of the same process here. So you're going to have to find the factors, like how I looked here is like, I'm going to have to multiply this by 3 and this by 2 to solve this. Okay. So let's start with a real simple one. Let's add the following. 3 over x plus 4 plus 2 over x minus 2. The first thing you're going to have to do is you're going to have to find the LCD. So look at this. This is one factor, all right? And this is another one. So what I'm going to do, and I know this is going to seem silly, is I'm going to build the LCD. I'm going to look and I'm going to say, okay, do these denominators have a common factor? No, they don't. This is x plus 4, this is x minus 2. So what I'm going to do is I'm going to bring down all the unique pieces. So I'm going to bring down the x plus 4, and then I'm going to bring down the x minus 2. So this is the LCD right here. So then the next thing what I'm going to have to do is I'm going to have to put each rational expression over the LCD. Well, look at this one, okay? It already has an x plus 4, so what is it missing? It's missing an x minus 2. So whatever I multiply into the denominator, I have to also put into the numerator. Add to it 2 divided by x minus 2. Well, look, it has an x minus 2. So what's the denominator missing? It's missing an x plus 4. Excuse me. So whatever I multiply into the denominator, I then multiply into the numerator. So now I can add. So this is 3 over x minus 2 plus 2 times x plus 4 all over the LCD. So now once you have this, now just simplify. So distribute the 3. So this is 3x minus 6. Distribute the 2. Plus 2x, and then 2 times 4 gets me plus 8. All over x plus 4, x minus 2. Well, 3x plus 2x gets me 5x. Minus 6 plus 8 gets me plus 2. All over x plus 4, x minus 2. So look, the hard part there, seeing that, the hard part there was figuring out what the LCD was. So if you look at like something like this, right, they have no common factors in the denominator, you're just going to bring down both factors, and that's going to form your LCD. All right, let's try a little bit more of a tricky one. Let's add these. So let's look at 5x minus 1 all over x squared minus 3x plus 2. And I'm going to add to it, sorry, it's a little bit not straight here, 3 over 2x minus 4. All right, so this is a little bit more complicated. All right, so the first thing I'm going to do, okay, is I'm going to factor the denominators. All right, this is going to help me build the LCD here. Okay, so the numerator is 5x minus 1 all over. All right, so what two numbers multiply to positive 2, sum to negative 3? Well, that's just x minus 1 times x minus 2. Plus, I'm going to factor out a 2 here. Okay. So now what I'm going to do is now I'm going to build the LCD. So the first thing I'm going to notice being like, do you notice how they both have an x minus 2? Okay, they both have a common factor. So my LCD is going to include just one of those common factors, x minus 2. What else? Well, this one has a factor of x minus 1. So the LCD is going to need an x minus 1. This has over here a 2, right? So this is going to need to be included in the LCD. So this is my least common denominator. So you factor, you look at what they have in common. They have an x minus 2, so I'm going to bring that down. And then I'm going to bring down the other missing factors. Whoop, x minus 1 and 2. So now the job becomes rewriting this as an equivalent statement, so I can just equivalent expressions. So look, this is x minus 1, x minus 2. It already has those. So what's it missing? It's missing a 2. So if I'm going to multiply a 2 in, all right, I'm going to need to multiply the numerator by a 2 as well. So now what is this one missing? It has a 2. It has an x minus 2. It's missing an x minus 1. So if I'm going to multiply an x minus 1 in here, I need to multiply that into the top as well. Well, now I can add. All right, so now this is 2 times 5x minus 1 plus 3 times x minus 1 all over 2 times x minus 1, x minus 2. All right, now begin the process of simplifying. So I'm going to distribute. So this is 10x minus 2 plus here, this is 3x minus 3 all over 2 times x minus 1, x minus 2. Well, let's clean this up. 10x plus 3x gets me 13x. Minus 2 minus 3 gets me minus 5. All over 2 times x minus 1, x minus 2. All right, so we got it. We got it. So we had to just build that LCD there. We had to build that LCD. All right, let's now let's do a subtraction problem now. A little bit more complicated here. All right, a little bit more crazy. So let's subtract this. X divided by x squared minus 10x plus 25 minus x minus 4 divided by 2x minus 10. All right, so the first thing you're going to have to do is let's factor these denominators. So this is x. Two numbers that multiply to 25 sum to negative 10. So they both have to be negative. And so that's just going to be x minus 5 times x minus 5 minus x minus 4 all over. So I'm going to factor out a 2 here, and it'll be left with x minus 5. All right, so LCD. Right off the bat, do you notice how they have 1x minus 5 in common? So I'm going to bring that over. All right, but now what else is missing? Well, there's a 2 here, so that needs to be part of the LCD. And there's another x minus 5. There's another x minus 5. So I'm going to have to bring that one last piece there. So if they have a common factor, you only bring 1. The reason I have this other x minus 5 is because there was 1 left over. So this is my LCD. So now I'm going to write over equivalent. I'm going to write equivalent expressions over the LCD. So this one is missing a 2, so I'm going to put a 2 in there. So I multiplied a 2 in the bottom, I multiplied 2 by the x up top. Minus, what is this one missing? It's missing an x minus 5. Notice it only has one x minus 5 here, but the LCD has 2. So now I'm ready to subtract. So this is 2x minus x minus 4 over x minus 5 all over 2 times x minus 5. And well, x minus 5 times x minus 5 is going to be x minus 5 squared. So you're going to have to FOIL this out and leave this negative out front here, okay? So this is 2x minus, this is x squared. It's going to be minus 9x plus 20. All over 2 times x minus 5 squared. Let's distribute the negative. So this is 2x minus x squared plus 9x, and then negative, the reason it becomes plus 9x was negative, negative is a positive, and then whoop, minus 20. All over 2 times x minus 5 squared. Well, 2x, you have this negative x squared. 2x plus 9x gets me plus 11x minus 20 all over 2 times x minus 5 squared. And there you go. We have it done perfectly here. So you can try to factor out a leading negative here, but then this trinomial won't factor anyways, because there's not going to be any two numbers that multiply to 20 and sum to 11 here. So or negative 11. So we're all good here. So as you can see here, you're just going to have to build the LCD. You're going to have to put each expression over the LCD. And you're going to have to go from there. And it's going to be a little tricky at first, as you practice this. But the more practice you get, the more you practice this, the easier and easier it will become.